Hello, this is Peter from OneCNC UK, and in this video we're going to take a look at some of the new features available when you upgrade your XR9 Professional to 10. So let's get started. Planar finish face has been totally revamped for either semi-finish or finishing cycles. This can be used in either 3, 4 or 5 axis positional machining, giving the users total control of the selected surface or surfaces. So let's go ahead and give you an example. We're going to go down into our model toolpaths. We're going to select planar finish, and then it is just a question of selecting the single surfaces or multiple surfaces. Now, depending on the angle that you wish to cut these surfaces on, they could be obviously picked as separate toolpaths. I'm just going to select them all for this example. So I'm quite happy with the tool selection, speeds and feeds. Clearance form is good. I'm going to zigzag. I'm going to zigzag through the y-axis, so 90 degrees. I'm going to use a maximum step over of 0.25 just for the simulation purposes. The boundary is the part that we're machining. Tool placement position, I'm going to allow the tool to start off the boundary, off the surface. Top of the job is 1, bottom of the job is the base of the program. And there we have it. Now, just before I do go into simulation, you can see I have got some roughing cycles in, and I've done a couple of finish passes up the wall. So we're going to simulate rest. We're simulating to a stock model. I'll just run the roughing simulation quite quick so you don't have to sit there and watch it, and I'll fast forward onto the finishing cycle. So the finishing tool's about to come in. I'll just change the color over so you can see the actual part being machined. And there we have our planar finish. Now you can see it is running off the side, so it's not leaving any visible witness on the edges. I will increase the simulation speed just so we can run all the way through. But with no need for multiple boundaries or complex boundaries, the added advantage for surface finish is due to the improved cost control and also having the benefit of reducing the programming time. The high-speed pocket entry in OneCNC has recently been enhanced with the addition of a new entry style. Previously, users were limited to either the plunge or helix methods when initiating pocket entries. Extensive real-world testing was conducted to evaluate potential improvements in the pocket entry process. Based on these practical assessments, a zigzag entry was introduced. The introduction of a zigzag entry method has demonstrated significant time savings compared to the traditional plunge or helix approaches. This enhancement provides users with a more efficient option for high-speed pocket entries. Pages allows you to turn a 3D model into a 2D drawing and add any dimensions required. So we'll just go into our pages. The first thing we need to do is select a page, a drawing template. So we can obviously pick any from the template library OneCNC, or you can create your own and import it. So we'll just use ANSI D, and then it's a question of selecting the views. So we'll go with the top view initially, and we'll simply add that to page. Now, before we add it to page, you do have the option of wireframe, options, model, or both. We'll just go with wireframe for this initially and add that to the screen. We'll then go for a front view. Again, we'll add that to screen, and you'll see the software locks onto the datum, so it's really easy to position the part. And finally, we'll just go for a right-hand view, and again, add that to the page. So let's have a look at putting a few dimensions onto it. We'll start off with a vertical dimension. And when you create any dimensions, you can tolerance them up. We'll go for another vertical one there. And to that little flange width. Do a horizontal one. Let's say there to there. And job done. So we've put all of the dimensional ones on there that we want to do. And as I say, we can go in then and tolerance them. You can also put solid isometric views in there. So if we go back to our pages, we'll just do an isometric view. We'll change it over to a model and add that to page. And we'll simply left click and put that up there. And let's just do one more from the top. Again, add that to page. So using pages, it's a very quick and simple way of creating 2D drawings directly off solid modelings. Another option that's now become available in 9 is the ability to export solid models as a 3D PDF. This can become extremely useful if you're sending jobs off to customers and they need to have a look at the part before they can decide whether there's any features on there they can and can't machine, or it could be down to sensitive documents that you can't export out solid models for, and they just really need a pictorial view to view over to make sure that the part can be manufactured. So we'll just go into our file. We'll export that file. We'll export as a 3D PDF, and we'll just call this sample PDF. We're going to go into our Adobe. We're going to go into menu. We're going to open. We're going to go back to the desktop. And we'll open sample PDF. So that's the imported PDF. You can obviously use the PDF tools that are built into it to dimension the part, to have a look around the part. And as I say, you can do all the dimensions available inside the document to be able to measure it. So very quick and easy and a very powerful tool. Enhanced CAD viewing. You'll notice when you first look at the screen, a 3D control cube has been added to the lower left corner of the screen. This allows users to easily select interactive 3D views, for example, top, bottom, front, right, left, and also isometric views, improving spatial orientation and eliminating any rotation confusion. And geometric tolerancing has now been introduced throughout the entire product range, no longer just being available in Expert. Smart Dimension intelligently selects whether you are selecting horizontal, vertical, arcs, or circles, and applies the appropriate dimensions automatically. The traditional manual dimensioning tools remain for any custom scenarios. OneCNC10 has also introduced advanced analyzing for lines and fonts in all CAD drawings, offering superior clarity in dimensions, annotations, and title blocks. Geometric tolerances, as I previously mentioned, are available throughout the entire range of OneCNC. This results in more legible, professional, quality drawings, especially for the GD and T documentation. OneCNC10 CAM enhancements. The new chamfering feature supports custom angle settings and allows the use of tapered tools, not just the standard 90 and 45 degree tools. The tool library has been updated accordingly, and multiple automatic passes are calculated when needed for optimal results. So let's go ahead and give you an example. So in this example, we're just going to use position number 1. We're going to go into chamfer and edge, give ourselves a start point, a direction, and right click to end as always. So if we just go into the libraries, as I said, the library has been modified to take all of the different taper angles that are now available, and obviously you can modify them to suit. We'll just grab hold of an 8mm chamfer tool. We'll just give it a 0.5 tip diameter. Not really bothered about speeds and feeds. So next. Quite happy with the clearance plane. As I say, this side of the form hasn't changed at all, apart from the graphics. The only difference you'll see, it does now offer you cut levels. And cut levels obviously come into play when you're using a smaller tool than the actual chamfer size itself. So we've got an 8mm tool. Let's do a chamfer size of 10mm. We're going to use cut levels, as I say. And when we select next, you can see all of these are auto selected. It calculates out the step over and the rough in depths dependent on the size chamfer and tool you've picked. They can obviously be overridden to suit. So for this one, we'll just leave the standard settings. I'm just doing a lead in and lead out slightly bigger than the tool radius and finish. And if I just right click and go to simulate rest, we're simulating to a stock model. I'll just slow it down as we go into it. And as you can see, it's just working along a single depth at the moment, just radially moving in at the given step over. Once it's finished this pet depth, it'll then drop down to the next pet level and work its way over at the same radial cut. And then finally, the cut right down at the bottom. So a very quick and easy way of modifying and creating chamfer cycles. So let's just go in and change a couple of these settings. So we'll go into edit. Let's say we thought the radial cut was a little bit gentle. So we're just going to untick the automatic. We'll say a step over distance of 1. We'll leave everything else pretty much the same. And we'll accept the form all the way through. And we can then right click and simulate. As I say, you'll see the radial cut is a lot greater than it was before. obviously depending on the material and the cut conditions you have. But a very quick and easy method of using chamfer tools to cut larger sizes. The new corner rounding function automates multiple pass calculation for accurate corner rounding, available in all milling and lathe multi-axis configurations. Users can expect better surface quality and improved life. So let's give you an example. So we're just going to go into our stock tool pass, corner rounding option, as usual, start point, direction, end point. We'll just change our tool over in the library. We'll go for an 8mm corner rounder and select OK. Again, I'm not really worried about speeds and feeds for this example. Clearance form is good. And we're going to use position number 1. So we're going to change it over to the outside. As I say, you can leave stock in Z for a finishing pass. It now offers us the roughing depth option, so we'll just go down in 2mm increments and we'll select next. We're just giving it a bit of a lead in, lead out, so it doesn't plunge onto the job, and finish. And we'll just do a very quick simulation with our stock model. So this comes in useful, obviously, for large corner rads, and as it states, it should give you a much better surface finish and tool life. OneCNC10 now offers us enhanced hole wizard. Hole features have been updated to allow for interactive model-based depth selection and improved feature recognition, saving time and ensuring consistency in repetitive tasks. This comes in especially useful when using things like drill hole single. Drill single, unlike drill hole wizard, does not give you the depth of the hole recognition. So when you're selecting the holes that you want to machine, we'll just go through the normal tool selection. When we come to the Pick Z option, now we can zoom into the bottom of the holes, find an anchor point at the base of the hole, and left-hand mouse click. And that is telling us that the hole is 20mm deep. We can then obviously accept the form all the way through as we normally would, making Hole Wizard exceptionally simple to use. Filleting in OneCNC10 has now been significantly improved to support more complex and difficult shapes. Edges that were previously failing or required workarounds can now be filleted cleanly, reducing workaround time. So on the screen, I have 2 separate solids, a boss and a cylinder. So first things first, as always, we will go into our model operations and union them together. And it's good practice just to remove any inner surfaces, you know, when you are joining objects together. We're now going to go into filleting. We'll chamfer an edge. We'll select the profile and right-hand mouse click. Now, as I say, the filleting has been dramatically improved. And if I just select undo, go back into filleting, I can now select a chamfer. And as you can see, no problems at all. A massive improvement to the modeling side of the software. Also, with file imports, file import capabilities have been further optimized for performance, capability, and reliability across all CAD formats. Thread modeling has now been introduced into OneCNC10, and the new thread modeling allows for both internal and external metric and Whitworth threads placed directly from the thread modeling. So let me go ahead and give you a quick example. So we're just going to go over into our solids. We're going to use the thread model, and we can create threads using the library, standard, custom, Whitworth, or we can create our own using the form on the left. So we'll just say pick a 12 by 1.75 at the library. Let's make it a little bit longer than that. Let's say 15 mil. We're doing an external thread and it's going to be right-handed. So we can simply select OK. And there we have it. Now, this is a solid, so you can obviously use modeling, internal and external. And if I go to my verification options at the top, you can see it is a solid. So this could be part of an assembly, part of something that you're going to send to a customer, and you want a more accurate representation of your part visibly. As you know, in OneCNC, you don't need a thread to be able to cut a thread. It could be wanted to 3D print or other options, only limited by our imagination. So let's just rotate this round. I'm just going to rotate it around the y-axis. Let's go 90 degrees. And let's open up the back end of the bolt. So, as I say, we could want just a more accurate representation of the part before we send it out to be machined by our customer.